Okay, class, picking up where we left off at, we're going down to this second problem here. It says the graph of f of x is equal to x squared, g of x is equal to x squared minus 4, and h of x equals x squared minus 9. Okay, first of all, we know that x squared is this gray line here, this light gray line here, and I will put these arrowheads here. But as you all know, all of these are supposed to have arrowheads, so I don't need to keep putting them there. But we have these arrowheads. Now, this is our x squared, or our f of x. Next, we have this black line here. Now, if you put this in your calculator, you notice when you subtract 4, the graph shifts down 4. So this would be our g of x. So this black line is our g of x, or black parabola. And then we come to the gray parabola. You notice that it's a minus 9. It's shifted down 9. So this would be our h of x. Now, of course, now let me just explain this. When we look at these graphs here, the proper way of writing this is to write x squared by the first graph, x squared minus 4 by the second graph, and x squared minus 9 by the third graph. But because of the lack of space, I just wrote these symbols here to let you know which ones we were using. Okay, now it says explain how the values of k affects the graph. It shifts the graph down if k is negative. And when we say shift it down, it's down that many units. Okay, so now we go here to our gray box. It says effect of k on the graph of f of x is equal to x squared plus k, or x squared minus k. So we have if k is greater than 0, we know that means that k is positive. The parabola is shifted up. If k is less than 0, which means negative, the parabola is shifted down. And it says the y-coordinates of the vertex is k. So whatever your y-coordinate is, that is your k value from your vertex. Okay, now we go to objective 3 on the next page. It says functions of the form f of x is equal to x minus h in parentheses squared. Okay, now this looks a little different, but if you notice here, we have our x squared, we have our x minus 2 parentheses squared, and we have our x minus 5 parentheses squared. Now we want to label each graph. The easiest graph to label is the f of x. We know it's this light gray. So this is our f of x because we've graphed x squared before. Okay, now let's take a look here. If you notice this next graph, the black one, if you notice from the point of origin, we shift to the right too. And then this darker gray, we shift to the right here 5 places. Now if you look inside these parentheses, do you notice we have a minus 2 here and we have a minus 5 here? So this is letting us know that these graphs are shifted over to the right when we subtract our values here. So we would have actually our h value. If our h value is after a minus sign, so it's minus 2, minus 5, that's how many places we would shift to the right. So if you notice here, this black line here is shift to the right 2 places. So we know that this is our g of x. And then this dark gray parabola here, we know that this is our h of x because it's shifted to the right 5 places. So it says here, explain how the values of h affects the graph. Now your h value is actually positive. It just has a minus sign in front of it. So if h is positive, it shifts the graph to the right. And then here, we want you to note, and we want to look at the negative. in the formula. Okay, now we're going to shift down here. It says the graphs, we have f of x is equal to x squared, g of x is x plus 3 squared, and h of x is equal to x plus 6 parentheses squared. So the first thing we want to do here is this. We know f of x is how we regularly graph the x squared. But this time what I want you all to do, instead of writing f of x, g of x, and h of x, I want you to write actually what they're equal to. So this light gray parabola here, we know would be x squared. Now we have to look at this black parabola and a dark gray parabola. Okay, now the black parabola. If we look here from 0, we will go to the left 1, 2, 3 places. So we know we're going over -3. For the darker gray, we will go over to -6. Now, if you look at the original formula, let me go back up here to this original formula. The original formula has x minus h. Now, when it's x minus a value of h, h is positive. Now, when we come here, we notice inside the parentheses, we have, I scrolled down just a little too much. We have in these parentheses a positive. So what this is really saying is, let me write this off to the side. This is really saying x minus a -3 in parentheses squared. And then this second one here is x minus a -6 in parentheses squared. Now we know this will give us a positive and this will give us a positive, but our h's are negative. So if we look here, it's -3. You notice that this graph with the black, this parabola that's in black, that shifted over 3 places to the left. So we know that this will be our x plus 3 parentheses squared. And then this darker gray parabola here, we know this, notice that this shifted to the left 6 places. So we know that that would be our x plus 6 parentheses squared. So we labeled these graphs and explain how the values of h affects the graphs. So we know h is negative, and it shifts the graph to the left. Now it says here, if h is greater than 0, the parabola is shifted right. If h is less than 0, the parabola is shifted left. The x-coordinate of the vertex is h. So the vertex form of a quadratic function, f of x is equal to a times x minus h parentheses squared plus k. So what happens here is this. X is your h and k is your y. So this is what's represented by the ordered pair of a parabola. So now we go to objective 4. We have the summary of graph transformations. Now, what we will have here, it says the general form f of x, the form parabolas x squared. We know we had ax squared. Oh, this is going to jump around a little bit. So hold on for 1 second. Okay, I took the liberty of adding in this chart here because as we saw earlier, it was shifting. So we have af of x is ax squared. That gives us a wider and narrower graph for small numbers, big numbers. And then a is positive, it faces up. Now we had negative f of x, where we had negative x squared, which is basically a negative a squared, which I should see if I can add that in there. A negative a squared, which means that it faces down because a is negative. Okay, now we have f of x plus k. So we have x squared plus k, and we know with a plus k, it shifts up. Now we have f of x minus k. Now we know with a minus k, we know that it would shift down. Now, f of x plus h in parentheses squared, we know that this would shift left because remember this h here would end up being negative. Now, last but not least, we have f of x minus h in parentheses squared. We know it would shift right because our h is positive here. Now, we scroll to the next page. I had to fill this out as well because I saw it was shifting. So we have example 1, fill in the table. Now we're given the function, and to find the vertex, we know our vertex is h and k. Our h here is this 7, and our k here would be this -5. So this is our h, and this is our k. And remember, in this case, h is positive. So we have opens up or down. Our A is positive, so we know it opens up. Now it's shifted up or down. Now we know it shifts down because our K is negative. And then shift left or right, it goes to the right, +7, because H is a +7. Now if we want to look at the, we can, but we don't necessarily have to do the x-intercept. The x-intercept here would be at 2. So we're actually done with these first values here. Next we come here and we have a little visualization on the side, which you don't necessarily have to do. Now we come here. Our vertex is -1 and -2. We know our h here would be -1, our k would be -2. And we know it goes down because a is negative. And then it goes down by 2 also because our k is negative. And then it will go to the left 1 because our h is negative. It looks as though our a, h, and k were all negative. So it went down, down, and left. Now we come here to h of x. We have 2 times the parenthesis of x plus 4. Now first of all, we know that our vertex would be, our h would be -4. We don't have a k, so it's 0. So it'd be -4, 0. Now we know it goes up because our a here is a +2. Now it doesn't shift up or down because we don't have a k. And then now for the shift in left or right, we know that h is negative, so it'll be left 4. And then you can follow this here at your leisure. Now we come here. It says, which is the narrowest graph? Now, if we look here, we know that that would have to be g of x. And that's because the absolute value of a is equal to 4. And we know that if it's greater than 1, the narrower it will get. The absolute value, if it's greater than 1, the narrower the graph would be. Now it says, what is the widest graph? Now we know it has to be k of x. And that's because the absolute value of a is equal to 0.25, which we know as commonly as 1/4. So you could put 0.25 or just 1/4. And we know that that is the smallest a. Now it said which graphs have 2 x-intercepts. Now, the one that has 2 x-intercepts, if we look here, we have the first graph here from this visualization, and we also have the last graph. So that is f of x and k of x. And we know the x-intercept means that it crossed the x-axis. Now we come here to example 2. It says here, let g of x equals -3 times the parenthesis x plus 2 squared minus 4. Place the vertex in the middle of the table and then find a couple points on either side of the vertex and place them in the table. Then graph by hand. You could put this equation here in your calculator. And if you don't know how to do it, please ask and I will show it to you. So this will give us a table from our calculator. And these are our values. Now, if you notice here, this will be our left value, this will be our right value, or our x and y value. Now, if you look here, it says state the domain. The domain here would be -infinity to infinity. That's graphed on your calculator. And then finally, it says state the range. And we know our range would